Merge sort. In this video, I'll be explaining you the sorting technique that's used to sort algorithms, uh, the arrays, or any type of thing which you need to sort. So let's start. Here's we have an example array of 8 elements indexing from 0 to 7, and you can see these elements are not sorted in any of the order, ascending or descending. Usually we take example for ascending orders, but they are not sorted. So merge sort is a technique of programming that uses divide and conquer, which means we first divide the problem into sub pieces and then solve each of the pieces individually, and then again combine back those pieces to get our original problem solved. So in this method we'll be doing the same. So we'll divide the array in subarrays and divide those subarrays into further subarrays until we get to individual elements, and then we sort individual elements and then again combine them to subarrays and solve those subarrays for sorting, and eventually we'll end up having a sorted array. So let's see how will it work. So first of all, for that we need to make it into subarray, we need to find the middle part of the array. So for this case we got our middle equals to 4. That means the two subarrays that we'll be going to create will having 4 elements, or at least first will be having 4 and the rest of the elements will be in the second array. So for this example we get these two subarrays with first 4 elements in the first subarray and the remaining in the second subarray. So the same process breaks down into furthermore, and we'll get 4 more subarrays with 2 pairs, with each pair having elements and they are cut off from the above array. So in a similar way we'll proceed until we'll get individual elements. So now as we get individual elements, we can stop our divide part of the algorithm. As you can see, we reach to the individual elements. So now we'll start solving each individual elements. So at first you can see after we got the individual elements, we have to combine them into pairs and solve them as they got into pairs as sorted. So you can see first 2 pairs are already sorted, we no need to do anything, but last 2 pairs they are not sorted. So let's just solve them. So 2 will go first, then 8, 5 will go first, then 7. Now it's pretty good. Each individual elements into the subarrays are sorted, but these subarrays in itself are not sorted, but we'll get in at the end. So now further combine the left 2 part and the right 2 part, and in a way that the elements we have to get from each subpart by each indexing, like first element from first array, then compare with the first element of the second array, then compare first element with this second element of the second array, and you can see by doing that we got our first subpart array with sorted elements. Actually for this example it's already got sorted, we don't need to do anything. But look at the right hand side part. Here you will see that 2, 8, 5, 7, they are not sorted. So let's just sort them. So 5, 8, 7, yeah. Now you can see each individual levels of first individual elements, then paired elements, then paired subarrays. They all are sorted within the elements inside them, all are sorted. But now we just need to put the elements of these last 2 subarrays into an individual array with sorted elements. So how we'll do it? We first have an array, empty array. Then we compare each element of these two arrays and check whether which one is smaller. So in this case, one is smaller, so it will go first. Then we again check, is 3 smaller or 2 smaller? So 2, so 2 will go there. So again we'll check, is 3 smaller or 8 smaller? So it's 3. So now we check for the each rest of the elements and we got our array sorted. So now, as you can see, each elements are done in the elements of the array, and you can see that the array is sorted 1 2 3 4 5 6 7 8. So we got our sorted array. So yeah, that's basically it. This is merge sort in 1 or 5 minutes, whatever it be. But you get the idea that first we take the problem, divide them into subproblems, work on those subproblems, solve them individually, and then again combine them back to the original problem, and you got our problem solved in a much and very efficient way. Thank you for watching.